first, there's good documentation on the new networking paradigm over on Docker itself. Be aware there's really 2 pages you have to go to. It says Docker container networking. You want to read through that. You also want to go to working with Docker network commands, and then configure container DNS and user-defined networks. Those are 3 pages, so it's a little bit more complex than linking previously, but it's going to be important to get to know this. You should start using it right away because it's much more flexible. Also, and it works much better, let's say, in something like Docker Compose. Docker Compose, which I'll do later sessions on, is moving heavily towards that. And if you know what this paradigm is, you'll get less confused when you see legacy paradigm stuff like the linking, as I said. So make sure you're taking a moment to read on through this and know what's going on. Okay, so let's go over and let's start doing some command line stuff. So Docker networks actually I might have old networks here. Docker network is a command you'll use to interact with networks. So let me show you can create, connect, disconnect, inspect, list, or remove a network. And actually, I don't think I removed the ones I was doing with tests before, so we might get an early chance to do that. So I have a Docker network list. There's more networks here than you need, so I'm going to remove a few. Backtier that you see, and D network demo and NSQ, those are some networks that I defined here locally when I was going through my run through before the show and practice. So I'm going to go ahead and remove those just to get down to the base image again. So Docker network RM, as you see above here, that's the way to remove a network. So Docker network RM, let me remove D network demo NSQ, and Docker network remove backtier. Okay, Docker network. So listing these are the default networks that come on every Docker host. So you'll have Bridge, which is the default network for everything. Everything we've been putting on it is Bridge. It has a network interface. If you were to inspect the containers, you can see the Bridge network interface. There's host network, which deals with the hosting machines network, and then there's none, which provides no networking interface whatsoever. And there's reasons why you might want to do that for things that are spinning up securely and you don't need access to the outside world, but 99% of the time you're going to be using a Bridge network. Additionally, there's ways to develop plugins for Docker so that you can develop your own robust networking. So, layer 2 networks or software-defined networks, there are plugins out there that exist for Docker to let containers operate over those independently. So those are very, very interesting, although for me it was a little complex to get into right now, so I'm not going to. But know they exist. If you're doing anything highly secure and you need to get into sort of layer 2 connected containers or something like that, there are plugins that allow you to do that. And if you're messing with anything like Onos or any sort of SDN orchestration software, there's some plugins out there as well for Docker containers that will let you put them on a SDN and use them in the paradigm that SDN is expecting. So that's something to be aware of. Okay. So we've gone, and one thing is inspect too. So let me go ahead and Docker inspect, network inspect. Bridge. So let's take a look at Bridge for a second. Some of the information you get back, and some of you might be used to Docker. I think it's called Docker inspect itself, and you have to parse out with some JSON parser some of the data there. This is a lot easier to get networking information out of. All of these networks come. So this is the default Bridge. It comes with its own subnet. Every time you go and add a new user-defined network, and I'll show you one shortly here, it provides its own subnet to that network alone. So only containers in that subnet can get on that's those subnet IPs. Containers can belong to multiple IP numbers, multiple networks, so they might end up having multiple IP numbers within the context of an individual network, and that's an intended feature, and it makes it more secure. But the easy way to find out what's on it is just go ahead and network inspect the individual network you're looking for. That should help out quite a bit. All right, so let me go ahead and I'm going to create a network. Well, actually, let me put up something to show you how this will work with just a standard Docker container. So if you remember yesterday, I was working on a web interface to show you sort of Docker files and how that goes. And I'm going to use that file again. So I had Docker run. I'm going to demonize. I'm going to name it public web, and I'm calling it df demo. I'm using that image. So I need to expose that port to the public. So actually, I'm going to go ahead and I got the wrong command here. Excuse me. And this is a Flask application, and I'm going to do a similar paradigm to what I was doing yesterday. I'm mapping host port 80 to the container port 5000, which is the default port for Flask. So if I hit return on that, it's going to start the container docker ps. You can see the container running. If I go over to my web app, if I were to, let's say, load this file here. That's already the cache from it before. So this is running on port 80 on the host machine. Again, this is Docker Toolbox on Windows, which is why you're seeing that IP number instead of the home IP. But anyway, so that Flask app loads this web page and brings it back just fine. It's running on, I mapped the container to port 5000 to host port 80, which is why it runs as a normal web page. If I go back and inspect that network, Docker, I can't type today. Docker network inspect bridge. That's the default bridge. You can see now that actual container is listed in this bridge network. It gives its IP4 address. This is you'll see that this IP4 address is actually different from the host address, and that's because it's on the subnet here of this bridge network. The only reason it's visible for my machine is I've provided that port argument. So that's some of the reasoning there. So let's say I go ahead and instead I wanted to put it on define my own network. So if we look again at networking, actually before I do that, let me back up. Let's go ahead and show you how to find ports on a container. So what we've been using up to now is Docker PS, and it brings back the details about a running container. If I did -A, it would give all containers. And this shows that port 80 is mapped on the host is mapped to port 5000 on the container. I can also do Docker ports and give it the name of the container. So public web. Whoops. I think it's Docker port actually. I would figure this out. I shouldn't do these late at night. Yeah, so if I do Docker port public web, that gives me the same information, but this actually annoyed me at first, so it's a little quirk and something to be aware of. You'll see the notation up here on PS. Ports gives you the host port first and what it's mapped to on the container. When you do this, it gives you the container port first and what host port that is mapped to. So I find that a little confusing, but it's just a little quirk of the system. So just be aware of that as you kind of work with these ports and use these commands to get a picture of what's going on with your containers. So let's go ahead back. I was going to go ahead and run another container. So let me define a simple network, and I'll call Docker network create, and I'll call this closed web. So if I create a network called closed web, you can see it listed in those hosts. If you don't provide a driver for the network, it defaults to bridge, by the way. You can see that's what happened there. So let me go ahead and I'll take a similar command to the one I just gave. And if I were to run something on that, it will, got the wrong command here. So. Oh, I'm in the wrong window. What it will do is run on that network. I'm going to take these ports out. If I provide net closed web, it will run on that container. I gave the wrong name, so I had a name collision there. I meant to call this closed web. It will run as a separate container. So the container itself is running, but you'll see nothing is mapped. So there's nothing I can do to get to that that web page. There's not a great way to show it, but there's no way to ping. You see there's no IP number or host port associated with it. So docker remove. If you provide docker remove, by the way, with an F command, it'll shut down a running container. I think you've seen normally you have to stop it and then do something and then remove it. But docker F closed. Bad. All right. So I'm back to my original container. All right. One of the other things is actually a more effective demonstration of that I think will be to put something on the none network. So I'm going to go ahead and actually do this command. So this is docker run demonized again, name closed web again. I'm mapping port 8080 on the host to port 5000 on the container, but in this case I'm using an explicit network of telling it to use the none network, and I'm using that same image. So I'll hit return here. If I go to try to load port 8080 on this, I should get nothing. So that should time out in a second. And that's because the none network provides no network interface. So if you're putting things in there, even if you're providing port numbers, they will not map to anything. So that's an important distinction to realize. Even if you look down here, there are that container is marked here. It has no address though because there's no network interface, and you'll see that there's no subnet reserved for that none interface as well. So there's nothing going to happen there. It's a good place to put if you really need something secure that maybe just outputs to a data volume or does something like that, or it's just a data volume itself. That's a great place to put those so that they're secure and isolated from the other containers. All right. So as I mentioned, there's no service discovery protocol in place with the normal bridge, but if you use a custom defined network, you will find that that is the case. So let me go ahead and create a network. I'm going to call it back tier. So if I docker network list, it shows me back tier. Closed web is still there. That's something I really don't need, so I'm going to actually close that out. So docker remove. Oh. So we're back to just docker, the standard one, and docker tier. So let me go ahead and start my Flask app again. All right, it started with nothing associated with no IPs, nothing like that. So I won't be able to get to it, and the default port of 80 won't be mapped to anything. So if I docker that, I have 3 containers running. Closed web is still running. I'll go ahead and shut that down in a second. You can see Flask app is running. That has port 5000, but it is not mapped to anything. I didn't provide a P flag at all. And if I were to go ahead and try to ping Flask app, let's say, I'm using a BusyBox to run and ping. This might be worth noting. I'm running docker run, and you see that new flag is --rm. That means when a container, if you remember, if a container has a foreground process, once that foreground process exits, the container exits itself. So but by providing --rm, that tells Docker to remove the container right away, then rather than just go into exit status. So I'm going to try to ping that Flask app. I named the app that app Flask app, and see if I can get it to come back with anything for me. It tells me bad address, which is what I would expect. And let me go ahead and Docker. I'll remove the Flask app so I don't get any anything that collides with what I'm doing here. So docker remove F, and this is that trick I use for removing a bunch of containers all at once. Might help if I got the command right. There we go. What am I I doing wrong? Docker PS. Oops, PQ. Sorry. I meant AQ or QA. Didn't matter. Sorry, I get the command wrong. So PSQ, which means you just get the ID numbers and all of them, which means even stop one. So Docker PS gives me nothing. All right, let's go back and Docker. So let me actually show you putting something on a separate network and how that's going to work for us. Docker network ls. I got Bacteria on here. Let me go back over here. Let me provide that same command I did before. So Flask app, I'm going to get that running again in the container. I have not provided it with any network connection, so it's just sitting out there by itself. You see port 5000, so there's nothing to connect to. Now, after it's up, I can add it to a network manually by providing Docker network connect, the name of the network, Bacteria, and Flask app is the name of the container that I'm connecting. So if I do that this time, if I inspect Bacteria, you can see that container is now in here. It's within the subnet of this the range of Bacteria, so it's running just fine. So were I to try to ping that, I think I showed you that a little earlier. Let me just show you again. If I were to try to ping it by its name, by the container name Flask app, you would expect that I would get nothing, obviously. And I'm going to remove it again. So if I ping, it just tells me bad address. I can't get to anything. Likewise, if I try to, well, there's no port map, so it's useless for me to show you that. If I add it to that container, if I add it to the this app that's going to do the ping to the same network, and I can do that at runtime, Service Discovery will allow that container to discover the Flask app container by its container name. So in this case, I'm doing Docker run. Still using the remove flag for when it's done running, it will remove itself, and I'm using this --net to add this at runtime to the Bacteria network. It's BusyBox again, doing ping 5 times in the Flask app. So when I hit that, this time it recognizes that name. So Service Discovery, because it's part of the same defined network in Docker, on this Docker host, it knows by the container name where it's at and has access to it. So it's able to do that. Likewise, if I wanted the curl, let's say, and get the web page that you were able to see earlier, output to my screen here, I get it. Now I can't show you that in a web browser because nothing is able to access that container or that page except things inside the network. My host machine isn't in the network, so there's no real way to get there. So that's the only way to do it. It's a good way to have containers that need to operate and be isolated from the public to be able to interop with one another. Having gone through the curl, I can. There's a few other ways to do this as well. You can do this through what's called the Docker Compose file as well. So let me go ahead and list the networks, and you can choose Bacteria, host bridge, blah blah blah. Using a Docker Compose file, I'm going to pull one over the window here, and I'm going to get to that in a different lesson, and I'm going to do a demo on it next week at our conference. I'm also going to do a bit about it in another video. I might get to that before the conference, but I'm not quite sure. What this compose file does, it's letting me define a network down here. I'm going to call that network, I'm using the bridge driver for it. It defaults to it. I don't necessarily need that, but I'm going to call it NSQ. And there's some magic stuff you'll see happening related to where this Docker Compose file sits. I'm going to bring up 3 separate images. This is for a worker process called NSQ, and this is going to bring up a router to manage consumers, and so that you automatically find them. It's going to manage the consumer itself, and it's going to manage the NSQ admin interface that you'll see a web tier through. So you can see through here, there's no ports exposed in any of these directives. There's only here are there. So while they will all exist inside this NSQ network, because that's what I'm specifying down here, they're able to access one another by their linked names, by the names of their containers. And the only one that actually has any public-facing interface whatsoever is this NSQ admin, which will be a web interface, and we'll see that in a second. So if I go over, and actually let me use a different interface here. So make sure I'm the right. So if I Docker, and this isn't intended for you to understand it in this broadcast, just shows more networking components. Docker compose up. It will run through everything, and NSQ pops up. All three containers are running. So if I go back over to my other command line and I Docker PS, it gives me all the containers. You can see these are all from NSQ. They all have different commands, so they're starting different processes, and they all have different sets of IPs mapped, but none of them have anything mapped to the host except for this interface here, which extends off the page, so you really can't see it. But it's only this one NSQ admin that does. So going back over here, if I were to, let's say, refresh this, then I get my NSQ look here. There's nothing in the streams, no topics have been published yet. And matter of fact, because the consumer is actually located off the network, there's no way I can send anything to the consumer. So this just would let me monitor the results to the admin interface on what's going on, but there's no way for me to interact from outside that user-defined network in Docker. There's no way for me to interact with the queue. So what I'm going to do instead, I'm going to go back and grab some of my prepared script here and pull out a command to curl a command to that instance. So I'm using a separate Docker instance here, and it's Docker run. I'm removing it again. In this case, actually I probably should have done that before. Hold on, Docker network list to show you what's happening. So you'll see a new network here that was spawned by Docker Compose, and that's what I mean by the naming scheme. This D network demo, it's based on the folder of that holds a Docker Compose. By default, there's ways to override that, but so that's why you see that weird name. But NSQ, you see the name I defined in the file. So that is the network that those containers are sitting on. Nothing else in any of these other networks can interact with it. The only thing that can happen publicly is the one that has an exposed port, which is over here. So knowing that now, I'm going to run a curl command to queue a message into the listener there. So I'm going to do Docker run again, remove when it's done running. I'm giving it the network declaration of putting it on network demo NSQ, and then I'm using the appropriate curl image to send a curl command with hello world out to that consumer. So you see here, I'm using the actual name from the container that I had before. So here's NSQ, that's its container name. So it's able to recognize that container by its container name because it's in the same network. So if I do that, I'm just going to put it in a topic called back to your MQ. If I do that, it's a successful result. If I go back out to the web page and I hit refresh, I have a topic of back to your MQ. There's one message in there, so that message was sent, and I can do that repeatedly if I want to send more messages and just keep sending them until I run out of patience with it. And that sends it all in. If I were to refresh this page, you see there's 5 messages in here now, and so because I'm putting stuff into that network, it's interacting with it. So this way I can separate, let's say, a web tier that might be sending requests from the database itself. I can put that if there was a fronting web page, let's say like that web app, and it was in the network, it could be only exposed, let's say, through port 80 for user requests, and only be able to interact through some backend scripting and the DNS server inside the Docker host. So that's a way to sort of separate and achieve that sort of separation of containers that we're looking at for security. All right, so and just to show you for completeness, so that container is there. If I were to try to reach that container in any other way, so let's say I did something like, well, there's nothing I can do to ping it, actually. I'm trying to think of an example. How do you provide a negative example in this case? There's nothing I can do to ping that container, so it is completely isolated. If I were to, let's say, run this command, let's try. Oh, so I know what you're saying. So we've seen we've been accessing web pages over the host IP. previous to this. So let's say instead we wanted to try to curl that same page, assuming it was on port 5000 because we know it's on and we do not belong to that network. If I do it, it failed to connect, there's nothing there. So I can't even connect through the regular port to get back some of these web application things. That's an important, and even if I go back to, let's say, another network, let's say the back tier network, that's also isolated. So if I do that, nothing will come back for me. So that's essentially how you go about isolating components from one another and how you end up linking containers. It's fairly easy to do. Conceptually, the hardest thing is just keeping track of what's in what network. Once you start getting into things like Docker Compose file for this, it makes it a lot easier, which is why I wanted to just peek at it. Doing this all by command line and trying to figure out what is in what container, it's a bit much to keep in your head, especially if it's a service that's running for a while. You really want to resort to things like Docker Compose, especially when you start getting into multiple containers running into multiple different user-defined networks. But it's a very powerful feature. It separates these containers from one another in a very secure way. It lets you isolate concerns for your application into the appropriate location, and it really provides you a lot of flexibility in terms of bringing up other containers into those user-defined networks, because there's automatic service discovery associated with them, but there is not on the default bridge. All right, so that's our bit about Docker networking. Next time we're going to get a little bit into Docker Compose, as I said. That might be maybe another week or so before I do it, because I have to head out to that conference. So if you're coming to the conference, I hope to see you at my little session on Docker Compose. A lot of this will build up to that. If you have any questions or comments, please leave them in the comments section here on YouTube. I will try to answer them as best I can. If you have anything to add or correct, please do that. I look forward to hearing from you, and thanks for taking the time to watch this. Take care.